On this 2019 to 2024 Ram 1500DT with the 5.7 Hemi P0351 is pointing at the ignition coil 1 primary control circuit. In plain terms, the PCM may not be seeing the coil 1 control circuit behave the way it expects. The truck may have a misfire, rough running, hard starting, or an illuminated MIL. Broadly, this can involve the fused relay output feed, the coil 1 control circuit, the coil itself, connection quality, or possibly the PCM. We're going to stay disciplined here. Prove whether the code is current, check the feed, check the control side, and only then make the call. This monitor runs continuously with the ignition on. The code sets when the PCM detects ignition coil 1 signal circuit current less than or equal to 0 amps for at least 1-2 seconds, and the MIL will illuminate. Before getting deep into testing, start with the basic system checks. First, use the scan tool to read codes in all ECUs and record the data. Save a scan report and the related recorded data for comparison. Then erase the codes, turn the ignition off for a minimum of 10.0 seconds, turn the ignition back on and reproduce the operating conditions that set P0351. Read the codes again. If P0351 returns, continue with the diagnostic path. If it does not return, treat it as an intermittent condition, instead of forcing a hard fault test result. Next, look at the codes you recorded. If ASD-related codes are present, check what they mean first and diagnose those before chasing coil 1 directly. If there are no ASD-related codes, move on to the coil feed test. Now isolate the 12.0 supply circuit by disconnecting the component harness connector. Connect the positive lead of the load test tool to the 12.0 supply circuit at the component connector and connect the negative lead to battery ground or a good chassis ground. Make sure the circuit is actually powered during the test. If it is a relay output, the relay needs to be energized and on. A load test matters because the circuit has to carry current, not just show voltage with no load. The load tool bulb used here has 6.0 ohms of resistance and draws approximately 2.0 amps of current, so it is putting a real load on the circuit. The load test bulb should be illuminated and bright. You can also compare voltage dropped across the bulb to battery voltage and compare bulb brightness to a direct battery connection. As a voltage drop example, 2.0 ohms of resistance in the circuit would make the bulb reading 25% less than the battery reading because the total circuit resistance would be 8.0 ohms. If the bulb is bright, go to the coil control circuit operation test. If it is not bright, repair the 12.0 circuit for an open or high resistance. If the fuse is open, check that circuit for a short to ground. Then verify the repair and confirm the code stays gone. A 12-volt test light can be used for load testing only if it draws enough current. A high-impedance test light that draws less than 0.1 amps is not reliable for this job. The tool should draw more than approximately 0.75 amps. If a PCM connector terminal has to be accessed, do not probe the PCM harness connector directly. Use the GPEC diagnostic adapter. Also remember that the adapter can add up to 1.5 ohms of resistance to the circuit, so keep that in mind when interpreting resistance checks. For the control side, connect a 12-volt test light to a 12.0 source and probe the coil 1 control circuit at the ignition coil harness connector. Crank the engine for 5.0 seconds and watch the test light. Stay clear of the fan, pulleys, belts, and moving parts while the engine is cranking or running, and do not wear loose clothing. If the light is brightly blinking, the control circuit is being pulsed and the path moves to spark plug inspection. If the light stays on constantly, check the control circuit for a short to ground. If the light stays off constantly, check the control circuit for an open or high resistance. If the control circuit test light is brightly blinking, turn the ignition off and remove the spark plug or plugs for inspection. Look for cracks, carbon tracking, foreign material, gap size out of specifications, and a loose or broken electrode. If any of those conditions are present, replace the spark plug. If carbon tracking is found on the spark plug, Inspect the ignition coil boot for damage and replace it if necessary. If none of those spark plug conditions are present, replace the ignition coil and spark plug. Then verify the repair and confirm the code stays gone. If the test light stayed on constantly during cranking, isolate the coil 1 control circuit and check it for a short to ground. The ignition must be off for this continuity to ground check. Disconnect the ECU and every component connector that contains the circuit being tested, then check for continuity between that circuit and ground. There should be no continuity. If continuity to ground is present, repair the control circuit for a short to ground, using the circuit path and inline connectors to narrow down the location. Then verify the repair and confirm the code stays gone. If there is no continuity to ground, continue to the coil and PCM driver check. If the test light stayed off constantly during cranking, isolate the coil 1 control circuit and check it for an open or high resistance. The ignition must be off when checking circuit continuity. Disconnect the ECU and the component connector for the circuit being tested. Before measuring the circuit, measure the resistance between the 2 DVOM leads. Then measure the control circuit between the component connector and the GPEC adapter. If the resistance is below 3.0 ohms, continue to the coil and PCM driver check. If it is not below 3.0 ohms, repair the circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. Before replacing a PCM for a coil driver issue, determine whether the ignition coil caused the driver failure. An internally shorted or damaged secondary coil circuit may be the reason the PCM coil driver failed. Remove the ignition coil controlled by the driver setting P0351 and install that coil into another coil location that did not have a fault set against it. Turn the ignition on, erase the codes, then start and run the engine for up to 1 minute. If the engine will not start, crank it 3 times for 10 seconds. Read the codes again. If a correlating fault sets for the new coil location, replace the ignition coil and replace and program the PCM, then verify the repair and confirm the code stays gone. If a correlating fault does not set for the new coil location, move on to connection checks. At this point, check any applicable bulletins, then disconnect the PCM connectors, related inline connectors if equipped, and related component connectors. Inspect the connectors and terminals for installation problems, damaged locks, corrosion, signs of water intrusion, seal damage, bent terminals, overheated or discolored terminals, push-back terminals, spread terminals, and poor terminal tension. Repair any conditions found. Reconnect everything fully and make sure the connector locks are engaged. Then erase the codes and operate the vehicle under the conditions that set the code. If P0351 returns after those connection checks, replace and program the PCM, then verify the repair and confirm the code stays gone. If it does not return, the wiring or poor connection problem has been repaired. The key with P0351 is not to jump straight to a coil or a PCM. Confirm the code, prove the 12.0 feed can carry load, read the coil control circuit correctly, inspect the plug and coil side, and only then make the PCM decision. For more diagnostic training, visit stepdiagnostics.com.